Okay, welcome to Unit 6 in the ITS course. This week, the modules we're going to focus on are sustainable transportation and institutional issues. So let's go ahead and dive in. So again, the first module is sustainable transportation. And as I noted a bit in the discussion, as often occurs in discussion of sustainability, people go right away to the environmental side. So most of the focus of this chapter is on the positive impacts that ITS can have on the environment. And traditionally and primarily, it focuses on by having more efficient transportation, less delay, which leads to less fuel consumption, fewer emissions, that improves the environment. There's a bit of a discussion about does this potentially induce demand, which is always a bit of a controversial topic, but that's the basic focus on this module is primarily on the environment. The next chapter or next module is on institutional issues. That is, I think, an interesting topic, and I can tell you from my experience working in ITS, this is a very real issue because, to be pretty blunt, most DOTs have been created as organizations that design, build, maintain, and operate roadways. And really the operate is kind of the smaller piece of it. So it's mostly design and construction organizations. ITS is different. There's much more of a focus on the operations side. So in some cases, it's just difficult to make these things work within the DOT themselves. And also, you've got such a focus on regional applications. We have many jurisdictions involved. Going across those borders can be relatively challenging too. So this module talks on a bit of those. And it's something that is, if you get into this field, you'll see it happens quite a lot, or at least it's quite a challenge. So let's see, and finally then the last focus of this week will be on the case study. This is going to be our final case study, and this case study is focusing on what they call civil design considerations in ITS, and we'll talk about that here in a second. So, but that's where we are, and then we're getting somewhat close to the end of the course. Next week, the case studies are done, but next week you're going to finish your ITS application design, where you're going to focus on the technology piece. I will get you comments back on requirements here before that, and then we will be moving towards the end of the course with the final exam the following week. So we're getting there. All right. So I'm going to present to you the slides for the civil design considerations for ITS implementation. And I'm not going to present all of the slides because a lot of the slides for the case study actually are general ITS slides. So I'll just try to focus on the main points for this particular case study. And this is going to be the familiar project for you. We're back to the issue of managing traffic around in this college town around a major event situation, and in particular we're going to look at where we place cameras. So that's the big consideration here is where to place cameras, how to handle power, communications, that kind of stuff. So what this case study is getting at is that we talk so much about ITS being high technology, IT, etc., and it is, but the reality is there's still a lot of field implementation. You have to build things, maintain, operate things, construct things, and so a lot of the things you learn about in the more traditional sides of civil engineering very much apply here in ITS. So the activities you're going to have here for this case study, and you'll be doing these individually, are number one, siting. Where are you going to put this camera so that it meets them? It gives you the most advantages. Number two, how do you get power? How do you provide power to that camera? Number three, communications. How do you make sure you can communicate with the camera? And one of the real challenges for a camera is it requires relatively higher capacity for communications versus things that are low capacity requirements like detectors, message signs, things like that. There's another task on structures. I pulled that one out because it does get a little bit into geotech and some things that I know there are a number of people in the course who don't have a civil background, and I don't think that's really the focus of the course, so I think it's better just to take that piece out. And then finally, the last task is on integration and testing, and that's an important concept that gets forgotten a lot too. How do you make sure that what you've installed really meets the requirements you've defined in your design process? So if you look here, like I just said a minute ago, this requires a lot of traditional quote-unquote civil engineering specialties. You've got the roadway design, signage, traffic control devices, structures. Certainly, you look here. Actually, one of the images you see here is in the Hampton Roads region of Virginia, and one of the real challenges they've had is the structural integrity of these overhead sign structures. They've had a few failures that have been very concerning. So just things like making sure that your structures to maintain signs, to support signs, which seems like a trivial matter, is not always trivial. Power, again, getting power to devices is often more of a challenge than you think, because in general you don't have power runs out to these locations on highways. Communications, that is becoming less of an issue than it used to be. And that is simply because wireless is becoming much more prevalent, much higher capacity. But in the older days, getting wireline, whether it's fiber optics or copper, to a site was a big issue. And finally, hydrology. You have to be able to deal with stormwater, and that can have a huge impact on ITS sometimes. So another important thing to consider is that these ITS projects don't occur in vacuums. Typically, you're going into constructed facilities and layering this on top of it. So you've got existing roadways. Ideally, you have some plans to work with. Sometimes you don't have anything more than old, scans of older drawings. You've got signs that are out there. You've got control devices that are out there. Again, you see all the things that are already out there, and the issue is how do we reuse what makes sense, create new what makes sense, and make it all fit together. So again, in this project, and it's again familiar to you, we've got the stadium, the campus, the downtown, and we've got major arterial freeway interchange, and we're looking at the camera location to try to best monitor the situation. So moving on here, for camera capabilities, again, the idea of a camera is that you are trying to be able to see what's happening, and you want to have the best line of sight. You have to be careful of the sun angle, because at times the sun can wash out your field of view. You want to think about your coverage in terms of your pan, tilt, and zoom. And the environmental resistance is a big issue. These are in very harsh environments. And you see the rest of the issues here as well. So again, that is, you want to be able to figure out what you need for a camera before you figure out where to put it. So for this project, you're looking at a line of sight for the northbound lane south of the interchange is a primary concern, but you've also got some other locations, and you want to be able to leverage your existing assets. So in other words, you might put the camera at a place that's best for the site, yet in that situation you don't have any power or any comm to take advantage of, so the cost goes up. So you have to look at those trade-offs. These slides just talk about, again, in the perfect world, you've got existing plans that you can work from. So in this case, I can use, in this case, you've got a profile view. I can use that to look at my line of sight, depending on where I put my camera. And then plan view, I can look at how far off the roadway I can be to put my camera. I can also use this to, if I have this cross section here, I see, if I have my structure in this location, I've got, I've lost so much height already based on the center line elevation. So you see here, this gives me environmental considerations. Here's a culvert. So I use these to basically get a better sense of where to put my camera. And then finally here, an intersection plan view. We've got a pretty complex situation where I have things like, here's my cabinet, I've got certain conduit and plant usage already. I know my dimensions here from my plan view. So this gives, you see here I have a pretty tight site, and where to put a camera here is not a trivial matter. And then you go to things like, where's the cabinet? Are there structures there? In many cases, the best structure used for a camera is a structure that already exists, because that saves an enormous amount of money and it makes it much easier. Again, going to power, you see some of the issues here. Sometimes you'll see solar used. That doesn't work as well for high power demand and also high power availability requirements, but it does work for many cases. But I think the bottom line, you think sometimes you need backup power, and as you said before, one of the things to consider is when the power is out regionally, your ITS system's out, and is that something you can live with for your particular application. Communications. Again, you have to think about things like bandwidth. Bandwidth is the same thing as capacity, really, from a communications perspective. Reliability. Security. Security is a bigger and bigger issue. And in fact, one of the things, there's been a lot of interest in what are called IP cameras. Cameras that just you put right on the internet to integrate into ITS systems. But that also makes it much more vulnerable to hack into than a camera that's traditionally just connected right to an agency-owned fiber network, for example. So this last mile, so to speak, can be challenging too, pulling off of a main communications line to your more remote site. So again, all issues. There's not a perfect solution. Like I said earlier, though, it is becoming much more manageable given the improvement in wireless technology in recent years. Okay, a big part of completing an ITS project these days is to really be able to show that these devices work and integrated into a system. So in other words, yeah, the camera should function fine by itself, but is it tied to your system? Can I control its pan, tilt, and zoom from a control software? And how do I go through and test that the system is working right? This is where good requirements makes a big difference. If I have good requirements and I say a camera must have the capability to pan, tilt, zoom, have this field of view, when you go through the acceptance testing for the system, which is something you do at the end of construction essentially, you basically go through those requirements step by step, and you figure out what meets, basically that all the requirements that you defined are met in the actual system. Okay, and then finally, and this slide is I'm not crazy about, to be honest with you, but there's you certainly have a number of other consideration in a ITS deployment. Is your infrastructure protected? Are you meeting all the external regulations? Sometimes, if you have something that's in the air, like a camera, and you're near an airport, you have FAA regulations to meet, etc. Infrastructure protection is a big deal. The roadside environment is very, very harsh in terms of things like rodents. I've seen many ITS cabinets where you have very sophisticated fiber optic communications that have been chewed through by mice and rats. You have extreme heat, extreme cold. You have physical security. It's amazing how often things will disappear from the side of a roadway if they're not properly secured. So these are all things that seem perhaps silly, but from a practical point of view are big, big issues in ITS. And again, I was a bit ahead of myself, but this integration and testing is a big issue. You need to make sure that that using the system engineering V process it also requires a very systematic, very thorough testing of a system to make sure that each requirement is met properly. Finally, the case study ends with asking you a bit about evaluation. And this is something that the DOT has pushed a lot. I think it's been done to some level of success, but it still needs more. And that is, can you go back to a system and be able to prove, or to measure how effective it is in meeting its goals? A very traditional, a very common approach for people is to say, okay, I got this thing done. Now let's move on to the next project, and not to kind of follow up and say, well, how well does this work? So the idea of defining good, having goals well defined up front, good performance measures, and taking advantage of those and using those performance measures for evaluation is really important. And that's exactly what I said a moment ago. So that is the end of the kind of the intro for this unit. I hope the week goes well for you. If you have questions or concerns, please do feel free to email me, and see you next week. Bye.